This is where we got to yesterday in here, yes? Okay, and I asked you to work on this one and the next one on your own, yes? So what I'm going to do real quick is I'm going to just write all the answers down. What should you be doing right now? Checking what you wrote, right? And if what you wrote is different than what I write, what should you do? Fix it. You should absolutely fix it. You can ask a question if my explanation doesn't make sense, but let me try to explain first and we'll go from there. Is that fair? Okay, so we said this one was called rational, and the domain is weird. I told you that yesterday, right? I told you the domain is weird because normally what we say is how far left and how far right, except we have to care about the middle right here. Okay? As this is coming closer and closer to 0, it's never going to get to 0 because 1 divided by 0, oh no, we can't do that. Right? We can't do that. So we say our domain is negative infinity to 0 and then 0 to infinity. That's a U. It means union. It's a set notation symbol. It means union and it means and. Okay? We say all real numbers, but x is not equal to 0 because it can't be, right? The range is the same because it goes all the way down and all the way up, but right here at 0 also you can't ever get to 0 for y because there's nothing you can put in for x that will give you a 0 for your answer. So negative infinity to 0 and 0 to infinity. And again, we say all real numbers, but this time y is not equal to 0. There's no maximum or minimum because there's no highest point or lowest point. As we're moving from left to right, what's up?
What's that U?
Can somebody tell him?
It's union.
Yeah. It's a union and it means and. Good job. Okay? So as we're moving from left to right across the page, notice that it doesn't ever increase. It increases nowhere. And because it increases nowhere, that means it decreases everywhere. Okay? So what's left is the end behavior. As x is scooting to the left, as x is going all the way to the left, the y is getting closer and closer to 0. And x is going to the right, the y is getting closer and closer to 0. We're going to fill in the table as -2, -1, 0, 1, and 2 for our x values. When we put in a -2 for x, I get -1/2. If I put in a -1 for x, I get -1. What happens when I put a 0 in for x?
0 is 0.
1 divided by 0?
1. You get 1. No, 0. You get -1.5. You get -1. You get nothing.
Correct. We get nothing. It's undefined. When I substitute a 1 in for x, I get 1. And when I substitute a 2 in for x, I get 1/2.
1/2.
Okay. What about an x-intercept? What'd you write? None?
And then the other one's also none.
Also none, because it doesn't cross either axis, right? Okay. So that was the first one that I asked you to fill in, and this was the second one I asked you to fill in. Okay?
Is the absolute value?
This one?
Yeah.
Good guess. We already did that one, though. Anybody else have a guess what this one's called?
It's quadratic function.
Quadratic. Okay? The domain is negative infinity to positive infinity, or all real numbers. The range is from 0 to infinity, which is y is greater than or equal to 0. The symmetry is about the x-axis. There is no highest point, so there is no maximum.
Minimum is 0, 0.
The minimum is 0, 0. It's the origin. It's the vertex of that parabola, right? As I move from left to right across the page, do you see that it's decreasing here
That's right.
and increasing here? So it increases from 0 to infinity, and it decreases from negative infinity to 0. As x is moving to the left, the y is going
Up.
all the way up, in fact, so infinity. And as x is moving to the right, y's are
Going up as well.
going up as well, all the way. What's wrong? We're going to do -2, -1, 0, 1, and 2 is my x values in my table.
3. Oh, no. Mine's -2.
Is it?
So I'm guessing.
How do I get it? How do I get the y value? What do I have to do with the x?
You have to square it.
I have to square it. So what is -2 times -2?
It's 2. 4.
4, -4.
Just 4.
It's just 4, right?
4,
Thank
sorry.
you. It's just 4. So what about 2? What about -1?
1.
1. And what about 0?
0.
0.
And what about 1?
1.
And what about 2?
4.
Very good. Where's my x-intercept? 0, 0. And where's my y-intercept?
0.
Okay. So did you get any of that right?
I got like literally up the phone.
Good.
I got the, where it says infinity, it's down to the end behavior, I got that right.
Okay, good.
And then also the x-intercept and the y-intercept, I got that.
Excellent. What about the rest of you? Did you get any of it right? Maybe 1 or 2 things?
I didn't
Good. That's a good start, right? Because I asked you to do it kind of like on the fly, and I asked you to do it cold, right? So it's okay. Now let's start working on this one. We're working together on this one. What does this look like it would be called? That's exactly what it's called. Okay, square root. Now, just to be clear, this symbol right here, that sign, is not called a square root. It's called a radical. I know that you think it's called a square root because that's what we always use it for, right? That's what you've always used it before this class. But in this class, we have to use it for multiple things. So I wanted you to make sure you understood it has a name, and it's called a radical. We're going to call this square root, this function a square root because that's what we always use it for, right? Okay, you'll see what I'm talking about here in just a second, right? Looking at the graph, tell me the domain. How far to the left does it go?
No, it doesn't. It doesn't go
0. 0.
It goes to 0. Does it touch 0?
No.
How could you know for sure? Plug a 0 in. Do you know the square root of 0?
No. It's 0.
It is 0, so you know it. So it does start at 0. So I have a bracket on 0, and how far does it go to the right? Infinity. So this we would say x is greater than or equal to 0. What about the range? How far down does it go?
It doesn't go down at all.
It goes down to 0.
It goes down to 0, and how far up does it go?
0.
0, so 0 to infinity. But this time we have to say y is greater than or equal to 0, right? Because it's talking about the range. Do you agree with the symmetry? Yeah, I can't, there's nothing like I can't fold it over for it to be on itself, and I can't spin it and make it be back to itself unless it's 360, and that's not symmetry, is it?
Yeah, so symmetry would be none.
Correct. Is there a highest point?
No.
Is there a lowest point?
Yes. 0. 0.
0. 0, 0, right? Okay. If I'm moving across from where I start, am I increasing or decreasing?
You're increasing.
So how far am I increasing?
I don't really know.
Like the whole way though, right?
Infinite.
So it's increasing from 0 to infinity. So now I need to put your memory to the test. Okay? Why did I use a parenthesis right here when my domain is a bracket?
Because we're talking about the interval.
That's a good way to put it.
Yeah.
Can you increase at a point?
No.
You can't increase at a point. You can only increase after the point, right? So I can't include the 0 when I'm talking about where I'm increasing. We're talking about the interval of where I'm increasing, not the end point. Will we ever use a bracket when we're talking about intervals of increase or decrease?
No.
That's correct. Good job remembering from yesterday. If I'm increasing everywhere, where am I decreasing?
Never.
Right, nowhere, right? Okay, so none. As I'm moving to the left, where's my y going?
Down to 0.
Down to 0. As I'm moving to the right, where are my y's going?
Up. Infinity.
Okay. This is the first time where we really have to pay attention to what I choose for my x's. I really want to, right? I guess we did a little bit with absolute value, okay? But I really want to pay attention to the x's. So I'm going to tell you the first couple that I want you to write down, and then we're going to figure out the rest. Or you're going to figure out the rest.
2 and 3.
Well, let's just start with these.
Okay.
Okay, and I think after our conversations with these, you'll know where to go here. Okay? When x is -1, what's y?
Undefined. 0. 0. Undefined.
It is undefined. Why is it undefined?
Because there's no negative.
There's nothing over here, right? Think about it this way. If I put in a -1 right here, what is the square root of -1? Do you know how to take the square root of negative numbers?
No.
Not yet.
Not yet.
Not yet. That's some foreshadowing, right? End of December, beginning of January, sometime about there, I'll teach you how to take square roots of negative numbers. Is that all right? Okay. But for now, it's undefined. Okay. What about 0?
0. It would still be 0.
And what about 1?
1, it would be 1. No, you square root it. Sean, you square root
So
it.
what is the square root of 1?
It's 1.
It's 1.
Yeah. Yeah.
I didn't disagree with you. I was just waiting till you figured it out. It's okay. All right. So now what do you think I should put next?
2.
Do you know the square root of 2?
1.5.
It's not. No, it's not.
1.5. No, it's 0. No, wait, no.
Like, I don't know it. I would have to look it up. Why should we do 4?
Because 2 is the square root.
I know the square root of 4, so I should choose 4 as my x because I know the square root of 4 is 2. So now tell me the last number I should choose.
10.
6 because the square root is 3. 6 because the square root is 3. We know that.
9. It should be 9. It should be 9. What is the square root of 9?
3.
3. Very good. Okay. What is the x-intercept?
X-intercept will be 0 to infinity. And beyond.
Or just 0, 0, right? That's my x-intercept. And what's my y-intercept? 0, 0 as well.
0, 0.
Guys, remember x-intercepts and y-intercepts are points. They're not like the domain and range over here. Okay?
What is this?
All right, what's it called?
Ladder. Wait,
It is.
exponential.
No, cube.
Yes.
I do want you to know this. Sometimes people call it a cubic.
Oh.
Cubic. Now, last period they were upset because they think in their head a cube as like a 3-dimensional object,
Yeah.
right?
No, it's not.
It is, right? Isn't a cube a 3-dimensional object? Where? In geometry, right?
Geometry, but we're in algebra.
We're in algebra 2 when we're talking about pair functions, and this is a cubic. Okay? Because it's x cubed. Does that make sense? Okay? What's its domain?
No.
How far left?
How far
It goes
down? Negative
Infinity.
Negative.
Because we're talking about left, right?
Yes,
And even
ma'am.
though it's going down, isn't it going left as it's going down?
Just going infinity.
Okay? So negative infinity to positive infinity, which is all real numbers. And my range?
It's going positively infinity, negatively infinity, to infinity.
All the way down and all the way up, right?
Oh, yeah.
Which is all the way, also all real numbers. You agree with the symmetry?
Yes, ma'am.
Yes.
Because if I took it and spun it around 180 degrees, isn't it the same picture?
Same thing. Same exact picture. Origin.
How do you feel about these two?
None.
I mean, I know what it says, but how do you feel about it?
We feel good.
Okay? Because there's no highest point and no lowest point, right?
Yeah.
All right. Increase and decrease?
Infinity. Infinity.
It goes up
Infinity
infinity
and down infinity.
negatively infinity.
So, guys, what does it mean for it to increase?
Goes up.
So, as I'm moving from left to right across the page, where is it increasing?
Infinitely.
Everywhere, right?
So,
So, where does it decrease?
Infinity.
no, it
Nowhere.
goes from top to bottom.
Listen to me. Listen to me. Time out. Time out. I'm going to take a time out. Okay? When we're doing intervals of increase or decrease, we start on the left side of the graph and we move to the right side of the graph. That's the only direction we can go. Okay?
So infinity
From the left side to the right side. So this whole time that my finger is moving, it is increasing. Do you agree with that?
Yes, ma'am.
So if it's increasing everywhere, where is it decreasing?
Nowhere.
Nowhere. So we write none.
None.
Okay?
Right again.
As we're moving to the left for x's, where is the y going? All the way down. As I'm moving to the right, where is the y going? All the way up. Do I need to be careful about x values that I choose this time? Or can I use the regular ones? Just use the regular ones?
Yes.
Yeah.
What does it mean for something to be squared?
To double.
To 3.
Not double, but I think you know what you're talking about. Multiplies by itself, right?
Yeah.
So what does it mean for something to be cubed?
Multiplied.
It's not times 3.
By itself.
Times
Multiplied by
self,
itself
times
3 times.
3 times, right? Okay. So what is negative 2 times negative 2?
Negative 2 times negative 2 would be positive.
Positive 4, and then times negative 2.
That would be
That would be negative 8.
Negative 8.
Okay.
We're the owners of this thing.
What about negative 1 times negative 1?
negative 1.
Times, sorry, we gotta go back. What's negative 1 times negative 1?
1.
Positive 1 times negative 1.
Negative 1.
Negative 1. What's 0 times 0 times 0?
0.
What's 1 times 1 times 1?
1.
And what's 2 times... Oh no. What's 1 times 1 times 1?
8.
1.
Wait, what times 1 times 1?
It's not 3. Somebody said 3 a minute ago, so I'm just going back.
1. I'm talking about 2. I'm talking about the
2 times 2 times 2.
8.
8. What about my x-intercept?
0.
0.
Wait, no.
No, infinity.
It's all 0. Oh my gosh, my 0.
Where does this graph cross the x-axis? 0, 0, right? It's a point. 0, 0. Where's the y-intercept? 0, 0. Okay so far? Okay. What's this?
Square and cube.
So kind of, right? Remember how a second ago I said we called that one square root because it had that radical symbol in it?
Yes.
But this one has like a little baby 3 in it, doesn't it?
Yes, so it would be, wait, square root
I
of 3?
need you to give me just a chance for a second. Can you do that?
Yes, ma'am.
Look back over here. It seems like this one should have a little baby 2 if it's a square root.
Yeah.
Okay? It does.
So it's just square root.
But we don't have to write it because it's what we most commonly use the radical for, right? I told you that a minute ago, right?
Yes, ma'am.
I said that's what we use the radical for most commonly, so we call it a square root. There's actually a little baby 2 there, but we just don't write it. For example, in a linear function, right here, What's the exponent on this linear function?
A 2. A 1.
A 1.
1.
And I don't have to write it because it's the most commonly used one. What's the coefficient in front of this x? A 1, but I don't have to write it because it's the most commonly used. It's the same thing right here for this 2 for the square root. It's the most commonly used, so I don't have to write it. So when there is a number that's there, like this, it's telling me what kind of root it is. So what kind of root is this? A cube root.
Cubic root.
Okay? Here's the graph. Look at the graph. Tell me the domain. How far to the left does it go?
Infinitely.
And how far to the right?
And infinitely to the right.
Correct. How far down does it go and how far up?
It goes infinity.
Yes, it does. So we also say all real numbers. Do you agree with the symmetry?
Yes, ma'am.
Okay. Do you agree with no maximum and no minimum?
Agreed.
Because there's no highest point or lowest point, right? Okay. Where is it increasing? Where is it decreasing? So for increase, you're saying it goes from negative infinity to positive infinity because it's increasing the whole way?
Yes, ma'am.
Okay, I agree with that.
And then it's going to be...
If it's increasing everywhere, where is it
There is no
decreasing?
decrease.
Correct. Very good. As the x's are moving to the left, what's happening to the y's?
It's going down. So negative infinity.
Very good. As x's are moving to the right, where are the y's going?
Going up, so just normal infinity.
Okay. You think it matters here which x values we use?
I think so. Yes.
Oh, yeah, yeah.
Guys, just the same way that we did here for square roots, why did we choose the ones we chose? Because we know the square root of them, right? So what should we choose here for the cube roots? Numbers that we know, right? I'll give you a start. I'll give you a start right here. What times itself equals 0?
0.
What times itself equals 1?
1.
So what else could I choose right here?
Are you serious?
8 would be a great choice.
That would be good.
Because what times itself equals 8? 2.
Negative 1.
-1. Because what times itself equals -1?
1.
-1.
And negative 8?
Okay, now wait. That didn't work out too well back here, though, did it?
No.
Right? Wasn't it undefined when we chose a negative right here?
Yeah.
But do we know what times itself equals -8?
Yes.
Yes, we do. So we can choose negatives for cube roots, can't we? So what is this?
Negative 2.
Very good. -2. Where's the x-intercept?
0, 0.
0, 0. And where's the y-intercept? Again, is it okay that those are the same?
Yes.
Yeah, especially when it's the origin, right? Okay.
Is this one called slump?
Slum?
Slump.
No, it's not called slump, but it's similar to that. Here's what I need you to look at first. Actually, what I need you to look at first is I need you to make a correction for me. I told you from the very beginning, if I mess up, I'm going to say I messed up on purpose, right? Okay? I need you to fix this because I typed in the letter. This right here should be a B. And even on the next one, this should be a B. If you would please make that correction for me, I would appreciate that. Okay? So while we're looking at both of them right now, I need you to realize that if I cover that up and I cover that up, aren't they the same?
Yes.
Okay? So they have similar names. Okay? They have similar names. And I think when I start telling you the names, you're going to remember them because this is one of the ones that you should remember from Algebra 1. If you don't, that's okay. I got you. Okay? Where's the exponent in this problem?
It's above the B.
It's above the b, which is where an exponent should be, right? And what do you notice is in the exponent?
It's an X. Not a
It's an
number.
x. That's the variable, right? When the variable is in the x, guess what the name of it is called? Sorry, when the variable is in the exponent, guess what the name of it is called? Exponential, right? But write it smaller, write it smaller. Watch what I do first, watch what I do. Because there's another word that we have to add right here. When it's falling like this,
Decrease.
close.
Decay.
Very good. So let's go ahead and write the name of this one down here too before we go on. What's this one doing?
It's going up, but I forgot the one for up. It's not
Very
decay,
good.
Or increase, so it would be gain. Grow.
Okay? Now I need you to understand the difference. Okay? Exponential decay has a b value, a base value, that is between 0 and 1. It's greater than 0 and it's less than 1. So do you see how I can say it's between 0 and 1? That's usually what we use. And in fact, I want to go ahead and write that down because we're going to need that for the table in a second. B is 1/2, right? Isn't that, don't you think that would be the most popular number people would choose between 0 and 1?
Yes.
What do you think the most popular number people would choose for this one is?
Probably the same thing.
What's greater than 1?
2.
2?
Yeah.
We'll need that for our table, right? Okay. So let's go back up to the exponential decay graph, the top one, and talk about the domain. How far to the left, how far to the right?
Infinity to left,
Infinity.
and then that one. I don't know.
It does go all the way. Can you see the arrow?
Oh.
Right?
Yeah.
Now, will it ever get, will it touch the axis?
No.
It won't. Okay? It won't. It'll get closer and closer to it, but we'll never touch it. Right? That'll affect the range, won't it?
Yeah.
Let's go ahead and write all real numbers for that one right there. So if it's going all the way to 0 but never touching it, we're going to say it goes from 0 to infinity because it goes all the way up. But this time we're going to use a parenthesis on the 0 and not a bracket. Okay? Here we're going to say y is greater than, just greater than 0, not greater than or equal. I accidentally wrote it, but I fixed it. Y is greater than 0. Okay? You okay with the symmetry?
None, because if you fold it, then it's not the same.
Yeah, it's not on top of itself, is it? Okay? Maximum, there's not a highest point. Minimum,
Yeah.
does it get to 0? So what should I write?
None.
Couldn't I have written that already? Right, but why didn't I? No, remember, if I'm tricking you, I'm going to tell you, right? I'm going to tell you, and that'll come later, because I have one that I'm tricking you on later. Okay? But we needed to have the discussion about that it's going to get closer and closer to 0, but never touch, right? Okay, increasing. Where is it increasing?
To the left.
It's going to actually, it's actually decreasing.
It's not,
It's
right?
0. There's
It's
no-
only ever decreasing, so there's no increase. That means it's decreasing everywhere, right? So from negative infinity to infinity. As x is going to the left, where are the y's going?
Up. Infinitely.
As x is going to the right, where are the y's going?
Negatively down. Negatively.
I agree that they're going down, but where are they going down toward?
Right.
Towards the x-axis.
Which is,
0.
yeah. Is it ever going to get to 0?
No.
No, but that's where it's headed to. Okay? God bless you. You may or may not be ready for this table. Okay? You may or may not be ready for this table. So what I want you to do for the table is just copy it down. When we get to talking about exponential functions, I will make sure that you understand it. Okay? If you don't understand it today, that's okay. So we're going to choose -2, -1, 0, 1, and 2. And we're going to write 4, 2, 1, 1/2, and 1/4. I promise you that's true. You can just trust me right now that it's true, and if you don't understand it later on, I'll make sure that you understand it. Is that fair?
Yes, ma'am.
Okay. X-intercept?
No.
Because it never gets to the axis, right?
Never touches, so
None. Zero.
None.
Y-intercept?
Y-intercept would be
0 to infinity.
One.
So-
One. Y-intercept 1.
You're correct. Can I talk about it real quick?
Yes. Ma'am.
Yes? So
Yes.
if you're looking at the graph, can you look at the graph sometimes and tell where the intercept is? Yeah.
Yes.
But if you didn't have the table, could you tell exactly where it was?
Yes.
Maybe, right?
Yeah, maybe.
But could you look at the table and know for sure where the y-intercept is?
Yes.
Because the y-intercept is where
The 0.
x
is.
equals 0, right? So 0, 1. Got it?
Yes, ma'am. Easy peasy.
These are really similar, aren't they?
Yes.
Is everything going to be exactly the same? No? Will the domain and range be the same?
Yes.
Yes. So let's go ahead and copy those down. Whoops. Will the minimum and maximum be the same? As the one above. Not as each other, but as the one above. Yes. Will the intervals of increase and decrease be the same?
No.
They won't. Not this time, right? Because what's happening?
It's increasing.
It's increasing everywhere. So if it's increasing everywhere, where's it decreasing?
Nowhere.
Nowhere. And how does that compare to the one we just did?
It was the opposite.
Literally
It's
just
backwards, right? It's opposite. Okay.
Literally just backwards.
What about end behavior? As I'm moving to the left, what's happening to the y's?
It's never. It's not. It's decreasing, but it's not going to touch the thingy.
So 0. And as we're moving to the right, what's happening to the y's?
Infinitely
Very
increasing.
good.
-2.
Again, the table I just want you to copy for now. We'll go into it in more detail when we get to exponential functions. X-intercept, y-intercept.
Last page.
Last page. Now, some of the other ones that you did not talk about in Algebra 1, I thought maybe you might have seen those at other times. This one I don't think you ever have. And I don't mean that disrespectfully. It's just never probably come up for you. Okay? Log? It says logarithm. L-O-G-A-R-I-T-H-M. And very similar to what we did a second ago, I need you to know that these are both logarithms. They don't look the same though, do they?
No.
Okay? They are both logarithms. They do have a specific names. This one is log base 10. And really, I didn't have to write the 10 because just like before when things were understood, in a common logarithm, the 10 is understood. Okay? In a natural log, it can actually be rewritten as log base e. We don't write it as log base e. We always write natural log. We always write ln. But that's the difference between these two. This one's log base 10. This one's log base e. Okay? Looking at the graph, how similar are these two going to be?
Pretty similar.
Pretty similar. In fact, only one thing's going to be different. What is it going to be?
The angle.
The table. Yeah, the table. Okay? So if we get the top one, really all I have to do for the bottom one is give you the table, isn't it? Okay? So let's get the top one done then. What I need you to realize, it's very, very hard to see on this graph, is that similar to exponentials, similar to exponential, how it gets closer and closer to 0 but never touches right there? Logarithms come from close to 0 but never touching and come out here. So if we're going backwards, it goes here but never gets to the y-axis this time. Does that make sense?
Yes, ma'am.
Okay. So what's the domain?
The domain is
Infinite. 0 to infinite.
But does it touch 0?
No, it's 1.
The other one, yeah.
It doesn't touch
It doesn't touch 0, so we say 0 to infinity. But the parenthesis on the 0. Good guess, though. So x is greater than 0. What about the range?
That, but opposite.
How far down does it go?
All the way.
All the way?
All the way down.
And how far up?
Just infinitely.
Yeah. So all real numbers. Do you agree with the symmetry?
Yes, ma'am.
No.
Wait, no, because if you flip it, it's still...
So you remember how a second ago I said I had a trick coming? It's
Yeah.
right here.
Found it.
Right? I ask you every single time, do you agree with the symmetry, didn't I?
Yeah.
Like we could go back on the recording and look. I ask you every time, do you agree with the symmetry? Do you agree with the symmetry?
No. This one should be...
None.
It should be none.
Yeah.
Very good.
Oh, you said what?
Sean, you can ask questions.
Is there any way that I can fold the paper? Because if I fold it this way, that'll push this line right over here on this side of the axis. Does it go on that side of the axis?
No, it should not.
Can I spin it like 180 degrees and it look like exactly the same thing it was before?
No.
No? Does that make sense now? Okay, good, good. Do you agree with maximum and minimum?
Yes.
Because there's no highest point, no lowest point, right?
Yes.
What about increase?
Infinite. And then decreases. There's no decrease.
Correct.
None decrease.
So, I almost wrote the wrong answer. What's the interval of increase? We said everywhere, right?
Yeah.
But in this problem, what's the domain?
Negative.
0 to infinity, right? It's not negative. There's nothing over here, is there?
No.
So it's just 0 to infinity. But if it increases everywhere on its domain, then it decreases nowhere. Just as a quick aside, I don't like talking about end behavior for this one, because in my head it doesn't make sense. Because it's saying as x is going all the way to the left, well, it doesn't go all the way to the left, right? It only goes to 0. Well, how far down, like, where's the y's going at 0? Negative infinity. I'm going to write the answer, I don't like it. Okay? As it's going to the right, where are the y's going? All the way up. Do you think it matters what we choose for the y's? Or the x's, I mean?
I think so, because it's logarithm.
So I'll tell you this is what I want to choose. I didn't expect you to know that. Respectfully, I didn't expect you to know that. That's why I just hadn't told you. Okay? When x is -1, what's y? When x is over here, what is y?
Negative. No.
Undefined. Very good.
Undefined.
When x is 0, what is y?
0.
Also
No.
undefined. Very good. So when x is 1, what is y? 0.
0.
I'm not going to make you guess this one. Okay?
0.
And this one is special. I chose it on purpose, right? I didn't go to 3 next. I went to 10.
1.
Because when it's log base 10, it's 1. What if this had log base 8 and I chose 8 right here? What would this be? 1.
It would be
It
about
would be 1.
like
It would be 1. What's the x-intercept?
1, 0.
1, 0. And what's the y-intercept?
None.
1. Okay, we only have a couple minutes before we finish, and I need to get you added to Google Classroom. So what do I want you to do on this part? I want you to copy it. right? What did we say about everything was the same except for the table? And if you'll remind me tomorrow, I'll give you the table. Okay?